Good day everyone! Hello Sir Ace, I am Leo Nino O. Maniwang, a student of Holy Name University Graduate School, and in this video, we will discuss hyperboloid of two sheets. So a hyperboloid of two sheets looks like two elliptic paraboloids facing each other. All its vertical cross-sections are hyperbolas, but the horizontal cross-sections are either elliptical or circular or sometimes do not exist. The two-sheeted hyperboloid is a surface of revolution obtained by rotating a hyperbola about the line joining the foci. So, in order to create this solid, we are going to rotate or have a surface revolution of the hyperbola using the line connecting the two foci. So, the standard equation of a hyperboloid of two sheets is given as x squared over a squared minus y squared over b squared minus z squared over c squared is equal to 1. In graphing a hyperboloid of two sheets, we need to graph the xy trace, the xz trace, and the yz trace to determine the intersection of the hyperboloid with all these three planes. So to determine the xy trace, we set z is equal to 0. To determine the xz trace, we set y is equal to 0. And to determine the yz trace, we let x equal to 0. So we have here an example of a hyperboloid of two sheets. Suppose we are going to graph the hyperboloid negative x squared over 9 plus y squared over 4 minus z squared over 9 is equal to 1. First, we need to determine the xy trace. So we set z is equal to 0. Substituting, we have negative x squared over 9 plus y squared over 4 minus the value of z supposedly is 0, so we have 0 squared over 9 is equal to 1. We can cancel out the z variable so that we have y squared over 4 minus x squared over 9 is equal to 1. We simply just reorder such that the positive variable comes first before the negative variable. This time around, we already have a hyperbola with the formula y squared over 4 minus x squared over 9 is equal to 1. Solving further, we have y squared over 2 squared minus x squared over 3 squared is equal to 1. Now we have the a, which is equal to plus and minus 2, and the b, which is equal to plus and minus 3. We need to remember that since our a is under the y variable, then therefore this hyperbola is facing upward and downward. Now we graph. So we have here the x-axis and the y-axis. We first graph our a. We have 0 and negative 2 and 0 and positive 2. Now we graph our b. We have negative 3 and 0 and 3 and 0. This time around, we trace our imaginary rectangle. Also, we trace the diagonal asymptotes. And since this graph is facing upward and downward, we graph our hyperbola, the upward, and the other one, this one. Now we are able to graph the hyperboloid of two sheets in the xy trace. So this time around, let's have the other traces. Now we have to determine the yz trace, we set x equal to 0. So we substitute x with 0, we have negative 0 squared over 9 plus y squared over 4 minus z squared over 9 is equal to 1. Now we can cancel out the x variable, and what remains is y squared over 4 minus z squared over 9 is equal to 1. And solving further, we have y squared over 2 squared minus z squared over 3 squared is equal to 1. And we have our a, which is in plus and minus 2, and our b, which is plus and minus 3. Now we graph, and here we have our z-axis and the y-axis. Now first we graph a to be negative 2 and positive 2. We graph b as negative 3 and positive 3. Now we trace our imaginary rectangle and our two diagonal asymptotes. So we have here the upper part and here the lower part. This time around, let us have the xz trace. So we set y is equal to 0. Now substituting, we have negative x squared over 9 plus 0 squared over 4 minus z square over 9 is equal to 1. Then we simplify, we have negative x square over 9 minus z square over 9 is equal to 1. Notice that what we have here is actually impossible to solve. There is no way we can have a solution for this equation. So a way of knowing the trace for this is using a parallel plane to that of the x z trace y equal to 0. So we need to look for a value that can make y square over 4 equal to 2. And that will be y is equal to 2 square root of 2. We substitute that to the original equation. We have negative x square over 9. Then substitute 2 square root of 2 square over 4 minus z square over 9 is equal to 1. Solving further, we have negative x square over 9 plus, that is 8 over 4 minus z square over 9 is equal to 1. And that will give us negative x square over 9 plus 2 minus z square over 9 is equal to 1. Transpose 2 to the other side, that will give us x square over 9 minus z square over 9 is equal to negative 1. And this time, let us multiply negative 1 to both sides, and that will give us x square over 9 plus z square over 9 is equal to 1. This is the equation that we are going to use in solving for the plane parallel to the xz trace, which is y is equal to square root 2 square root of 2. So we first have the equation x square over 9 plus z square over 9 is equal to 1. And we see that it is actually a circle in such a way that it is x square plus z square is equal to 9. And solving further, we have x square plus z square is equal to 3 square. This is a circle with the radius of plus and minus 3, or simply 3, and the center at 0, 0. Now we can plot this circle. This is our x-axis and this is our z-axis. So the center is at 0, 0. We have the radius at 3. So we plot 4 points around the center and trace this point to make our circle. This is how the circle looks like. So this is the xz trace. So this is the graph of the hyperboloid negative x square over 9 plus y square over 4 minus z square over 9 is equal to 1 would look like. And notice that this is in a 3D space, such that if we have it this way, this is the xy trace with the red horizontal line as our x-axis and the green line our y-axis. So this is actually a hyperbola in this view. So we suppose that z here is equal to 0. If we rotate it this way, okay. See that this is still a hyperbola on the other side. But if we look at it at the other angle with y equal to 0, notice that this looks like a circle. You see that this actually looks like a circle. So this is the graph of the hyperboloid in 2 sheets with the equation negative x square over 9 plus y square over 4 minus z square over 9 equals 1. Second example, let us have the graph of the hyperboloid x squared over 4 minus y squared over 9 minus z squared over 16 equals 1. To determine the xy trace, we set z equals 0. Substituting, we have x squared over 4 minus y squared over 9 minus 0 squared over 16 equals 1. Now, we can cancel out the z variable such that we have x squared over 4 minus y squared over 9 equals 1. That will be simplified further as x squared over 2 squared minus y squared over 3 squared equals 1. And thus, we have the value of a to be plus and minus 2 and the b to be plus and minus 3. graphing, we have this our x-axis and our y-axis. Our A is -2 and +2. Notice that our A is on the x-axis because the A is under the x variable. And we have our B, which is -3 and +3. This time we can trace our imaginary rectangle and our two diagonal asymptotes. And notice, since our A is along the x-axis, then we can say that our hyperbolas are facing to the left and to the right. So this is our hyperbola, the left side, and the hyperbola on the right side. There you have it. This time, let us have the xz trace. So let us set y equal to 0. Substituting, we have x squared over 4 minus 0 squared over 9 minus z squared over 16 is equal to 1. Solving further, we have x squared over 4 minus z squared over 16 equals 1. And thus, we can simplify that further to be x squared over 2 squared minus z squared over 4 squared equals 1. And we have the value of our A to be plus and minus 2, and the value of B to be plus and minus 4. Graphing, this is our x-axis and this is our z-axis. This time, let us have A, it is plotted along the x-axis, so this is -2 and 2, and B plotted along the y-axis, that is -4 and +4. This time we can trace our imaginary rectangle and our two diagonal asymptotes. And since the hyperbola is facing to the left and to the right, we can trace our hyperbola here and here. Let us now determine the yz trace by setting x equals 0. So in setting x equals 0, we have 0 squared over 4 minus y squared over 9 minus z squared over 16 equals 1. We can cancel out the x term such that what remains is -y squared over 9 minus z squared over 16 equals 1. But again, there is no way we can have a solution for this equation. So the other way around is we look for a value that can make x squared over 4 equal to 2, and that is the value x is equal to 2 square root of 2. Substituting 2 square root of 2 to the equation, we have the square of 2 square root of 2 over 4 minus y squared over 9 minus z squared over 16 equals 1. Solving, we have 8 over 4 minus y squared over 9 minus z squared over 16 equals 1. And we simplify, that's 2 minus y squared over 9, then copy -z squared over 16 equals 1. Transpose 2 to the other side, that will give us -y squared over 9 minus z squared over 16 equals -1. And this time, multiplying -1 to both sides, it will give us y squared over 9 plus z squared over 16 equals 1, which is actually an equation of an ellipse. Now we continue with solving the plane parallel to the yz trace by setting x equals 2 square root of 2. We have the equation of the ellipse y squared over 9 plus z squared over 16 equals 1. Now, we can simplify that further as y squared over 3 squared plus z squared over 4 squared equals 1. And we have the value of our A to be plus and minus 4, and the value of B to be plus and minus 3. This time around, it is an ellipse, and we know that the major axis is along the z variable and the minor axis is along the y variable. So we can have the graph. This is our y-axis and the z-axis. Again, we first trace our A. So here is -4 and +4 along the z-axis, and -3 and +3 along the y-axis. Now we can draw our ellipse here, and this is how the ellipse looks like. This is how the graph of the hyperboloid x squared over 4 minus y squared over 9 minus z squared over 16 is equal to 1 would look like. So again, we are graphing using GeoGebra calculator suite, and we can see that in this, alright, if we have it this way, we have assumed z is equal to 0, then it is a hyperbola facing sidewards with the red horizontal line as our x-axis and the blue line our y-axis. So we can actually flip that here, rotate, and if we look at it right here, this is actually an ellipse. So this hyperboloid would look like an ellipse if we look at it at x equal to 0. So this is actually elliptical. So that is why we were able to solve the equation to be elliptical here. So that's it. That's how we graph a hyperboloid. These are our references for this video. And that would be all for today. Thank you very much. Ad Maiorem Dei Gloriam.